what we're going to do is we will talk about what is a Webpack. So what Webpack is and how to use Webpack. All right, so the first thing that we're going to do is, okay, so let's see here. So basically a Webpack is a dependency graph. I don't know how many people know what is a dependency graph. So before we get started about Webpack, let's make sure that we know what is a dependency graph. So a dependency graph is basically a directed acyclic graph. So which basically defines how you are requiring your libraries, your assets, and so on, and what depends on what. So for example, let's say that you have packages A, B, C, D, E, F. One could be a CSS file, JavaScript file, some image asset, and so on. So let's say A depends on B, and A also depends on C. And let's say that C depends on D, and A also depends on D. And let's say that C depends on B. So, and let's say that B depends on D and E. So, right, so this is some kind of a graph of dependencies. And so this is called a directed acyclic graph. Acyclic graph. Directed because, the directions represent what depends on what. Acyclic because if you have a cycle, that means that, let's say, like if there was a cycle between B and C, it would mean B depends on C and C depends on B. And so things wouldn't really work if there were cycles. So in terms of requirements, it has to be acyclic. And it's a graph, so this is a DAG. All right. Now that we have a directed acyclic graph, we can also define on it what is called a topological sorting. Okay. So what is topological sorting? It's basically if we were to sort this directed acyclic graph in a way that the things that don't depend come out first. So for example, A has to come after B, D, and C. Okay? And so E can come first because E doesn't depend on anything, right? And C depends on D, so D has to come before C. B also has to come before C. And D has to come before B. So we have D, then B, then C. So let's check. So E doesn't depend on anything, we're good. D does not depend on anything either, so that's good. You could have switched E and D if you wanted, because neither depend on anything. B depends on both E and D, and it came after. C came after E, D, and B, and A came last. So this here is a topological sorting on this DAG. And so now that we've sorted it, we know that, okay, we could first require E, then we can require D, B, C, and A, and we would be good with our libraries, and we would not have any conflicts or issues. So now that you understand what a topological sorted on a directed acyclic graph is, let's go back to learning about Webpack. So Webpack here, I will basically use this, okay? And all right, so we're going to discuss how it compares with Grunt, Gulp, Browserify, Brunch, etc. And you know what this means. So, all right, so you understand what is a dependency graph, and require is kind of a statement to require things inside JavaScript. In normal JavaScript, you cannot require images and so on, but with Webpack, you will basically be compiling all of that. And so you can require things like images. So historically, what you would have to do is basically include different things like jQuery min and then some jQuery plugin and main.js in order. And you had to manually do that because you didn't have this dependency graph Webpack. And you would have lots of HTTP requests and it would get slowed, right? So now you said, okay, well, let's require all of these scripts in an array and then concatenate them and uglify them and write them to a bundle JavaScript. And in our HTML, include this bundle JavaScript. Now, still, you were basically having globals and you were overriding globals in the plugins, and then things could become messy. So, and then you can have versioning. And so now with ES6 and CommonJS and Webpack, you can now do a true dependency graph. So you can put your version and require the JavaScript with that given version. And browser is basically client-side JavaScript. Node is basically going to do your server-side JavaScript. And browser does not support require. Node supports require, but does not support require for things like images and so on. So what does Webpack actually going to do here? So like here you have image source, and then you have this JavaScript in braces, which is basically require, and you're requiring a PNG image, and JavaScript doesn't allow that. So what's going on? So basically your Webpack has this loaders file, which is saying that, hey, you know, if I see something with an extension of PNG, then load it like a file. And what that will do is it will put a URL there for that image, right? So it'll basically say image source, and then it'll have a URL in me for the browser to see. So based on the rules defined in the loader file, Webpack will precompile all your require statements. And you can specify then with Webpack like things like, hey, I want to use this CDN for my images. Now, another thing is that, you know, you can also tell Webpack that I want to actually put all of these images in my dist folder, distribution folder. And so now you can make sure that, okay, all my images and assets went in the distribution folder and got loaded off my CDN. Okay? Grunt and Gulp, these are basically automation tools for build, but they don't really have this dependency graph kind of concepts and stuff. And Browserify basically is a tool to transform all those require calls that work in Node to work in the browser. But it's also not a dependency graph. So there's other stuff like Parcelify, but you have to kind of go out of your way to make those static assets like images work with that. Okay, and so the good thing about Webpack is basically you can compile exactly the stuff you're going to be using in your dist folder, and you can eliminate all those dead assets that you might have been including in your pages. Code splitting is easier because now you can specify which CSS things are going to be actually included for that given JavaScript or that page, which can reduce your file sizes. And you can control how the assets are processed. So like if an image is small enough, you could base 64 it, or if an image is bigger, or you can load it, your JSON file from a URL or so on. And you can automatically parse your less or Sass files into CSS. So you get a much more stable production deploy. You're not missing dependencies, versioning, and based on how those dependency graph work, you'll have a much more stable production. It's great when you have lots of assets and CSS and JavaScript and things. There's another cool thing which we can do, which is hot page reloading. And the way that works is basically Webpack has this thing which is a dev server, which is a small Express app in the main stack. And you simply have a JavaScript which is pointing to the server. So like localhost 8080 assets bundle.js. And then this bundle.js is being live reloaded. And so with Webpack, you can get the updating of the assets in a live way. So let's say you change your CSS, play around with it, you get a hot reloading simply by including this JavaScript pointing on the server, the bundle. Okay? And there's some bad things about it as well. It's only maintained by one person, and the mini string language this guy thinks is pretty bad. The documentation's not the best, and source code is hard to read. But the good thing is that the React community is adopting Webpack, and so are other JavaScript communities, and so hopefully the amount of Stack Overflow help you can get will keep increasing. Okay, so that's the dev server, and we talked about, with this kind of front-end programming with Webpack and splitting your code up, you don't have to rely on global variables and keep being a human compiler of your dependencies, and so you can use a dependency graph. All right, so that's it about Webpack and dependency graphs. So hopefully you liked this video, and